Hello, you grade Algebra 1 students. I just want to go over what we did this week. If you're unable to see hi Algebra 1 students. I want to go over what we did this past week. If you're unable to be on my Zoom meeting, this will catch you up. So what we went over this week was the key features of parabolas. A parabola is a U-shaped graph of a quadratic function. Here's what a quadratic function is, and here's what it's not. And looking at the results of the video that you guys watched, some of you were a little confused still. So a quadratic function is where the highest exponent of any of the terms is 2. We'll deal with this last one in a minute. But notice all these three have the highest exponent is 2 out of all the terms. 3 here doesn't even have a variable. This doesn't have an exponent, it's really a 1. And this has a 2. And here this has a 2, and that's just a constant number 6. Now let's look over here. Sometimes it's easier to figure out what something is when you see what it's not. This one doesn't even have an exponent. It does if it's in a different form, but that exponent would not be 2. This function here has a 2. However, it also has a 3. So here the highest exponent is 3, not 2. A quadratic is where the highest number in the power is a 2. If it's any higher, it is not quadratic. Here you have a 2, but this is really written as something else. It's really written as x to the negative 2. Some of you may think that 2 and negative 2 are the same. It's not. Negative 2 is not 2, so this is also not quadratic. And this one here, just kind of silly, I made a mistake. I have a term with an exponent of 2, but I have a term with an exponent of 3 and 5. So this is not also, because here the highest exponent is 5. So this kind of summarizes what happened in the video you watched. This last one here is actually going to be a quadratic because when we multiply two binomials, which we learned how to do last week, it turns out to be a quadratic trinomial. This would become, and as you can see, the highest exponent is a 2. So even that last one is a quadratic. So now let's get into the meat of things. Now that you know what a quadratic function looks like, let's look at what a quadratic is. We already said it graphs as a parabola. So here is a parabola. A parabola is a U-shaped graph. And everyone can see this looks like an upside down U. But that's okay. A parabola can be an upside down U or a right side up U. And this graph here is specifically the graph of the function y equals x squared minus 7x minus 10. And it is definitely a quadratic because of that x squared. I have another equation underneath it. And believe it or not, this y equals negative, parentheses x plus 5, x minus x plus 2, is this same parabola. Because when I multiply this out, I get that. So this first function is called standard form. The second function is called intercept form. And we're going to go into that more as the weeks pass. And what I want you guys to do here is actually recognize the key parts of a parabola. Why key means it's important. And why they're important is because we use them to answer questions. In fact, when we start getting into the word problems, what we did this week, we said the rocket. We were looking at the path of a rocket and pretend this was the path of a rocket. It started at the ground, it hit a high point, and it went down. Well, why these points are key is because this top point here will tell us how high the rocket went. This point here will tell you that it started on the ground, and this point here will say that it ended on the ground. And the difference between the two in our example in the video was that it was how much time had passed. So these are important because it tells something about the story. So the highest or lowest point in a quadratic function is the vertex. And the vertex here is the highest point of the graph. Therefore, it is a maximum because it is the highest. It would only be a minimum if it was the lowest point. Now, what I mean by the highest, if I am jumping up like on a trampoline, I go up, I hit a high spot, and eventually I have to come back down. Now, this opens up or down talks about the shape of the parabola. This parabola opens down, and how I remember it is these are really arrows that make the parabola continue on forever. And if they continue on forever, I put arrows here, and these arrows are pointing down, so this opens down. That means it's going to get, the y value is going to keep getting more and more negative. The next important thing about a parabola are the zeros. And the zeros are important because they actually are the solutions to whatever the question is we're trying to answer. So the zeros here are -5, 0, and -2, 0. And if I had a question, and I can't think of a question that would use negative, but if I had a question that I wanted to answer and I wanted to solve it in a quadratic equation, I'm looking for the zeros, and those would be considered the solutions. And that's the reason why those 2 points are considered key. The second to the last key feature is called the y-intercept. Now, if you guys remember, the y-intercept is where the graph crosses the y-axis. So I'm going to go ahead and extend the y-axis further down. And then I'm going to take this parabola and I'm going to extend it further down. And I don't know how well I can do it, but it's going to be down there somewhere. Eventually, even though I don't see it, eventually this parabola is going to cross the y-axis, and that's where the y-intercept will be. I can't tell what that is on this graph because I don't have the accuracy I need. However, I will lead you to a little clue. The y-intercept is 0, -10, and I can tell you where that comes in 2 places. The first place is up here, -10. That constant term is the y-intercept. The second place that comes from is I can figure it out algebraically. I can use our function y equals -x squared minus 7x minus 10 to find out what the y-intercept is. And how I can do that is I know the y-intercept always has an x value of 0 every single time. So what we're going to do is we're going to figure out what the y value is when x is 0. And all I did here was I substituted 0 for x in both places. And if you do the math, 0 squared is 0. -7 times 0 is 0, so all that's left is 10. So that's how you can figure out the y-intercept algebraically. The last key feature is called the axis of symmetry, and in some places they call it the line of symmetry. And the line of symmetry is this dashed line that goes through the vertex and it cuts the parabola in half. Now, symmetry means if I were to cut this parabola exactly in half and I folded it over on each other, this side of the parabola would lay right on top of that side of the parabola. In other words, every point on either side of this axis of symmetry is symmetrical. This ordered pair -5, 0 is exactly 1.5 units away from the middle. This ordered pair of -2, 0 is exactly 1.5 units away from the middle. So this axis of symmetry, we write as an equation. We say x equals -3.5, because that is how you describe a vertical line. And you'll notice -3.5 is the same as the vertex, because it goes through the vertex, and it goes through the x-axis at -3.5. So those are the key features of a quadratic. This next page just allows you to do it yourself. I'm going to put up the answers, and I want to make sure that you understand it. This now we have a quadratic function of x squared plus 2x minus 3. The vertex here is -1, -4. This, I would say, opens up because my arrows point up. This vertex is actually a minimum point. The maximum or minimum is always describing the vertex. And it has a minimum point. It will never have a maximum point. This parabola will never have a maximum point because these arrows mean it goes on forever. If it goes on to infinity, there's no maximum. However, we know the lowest this will ever go is -4 on the y-axis. The zeros are the x-intercepts, -3, 0, and 1, 0. Here we actually see the y-intercept. So these are the zeros, vertex, axis of symmetry, which is x equals -1. That's that imaginary line that goes through and cuts the graph in half, and it goes through the vertex. Zeros, let's see, this is the y-intercept. The y-intercept is where the parabola crosses the y-axis, and therefore the x value is always 0. And remember, the standard form of the equation also tells us that it's 0. So the next thing I'm going to do is just summarize all this. This is what I wanted you to focus on this week. And I have the definitions here. And it would be good for you to actually pause this video and take these as notes. The vertex is important. It is the lowest or the minimum or the highest point on the graph. A parabola will always open up or down. Notice, if it opens up, it has a minimum. If the parabola opens down, it has a maximum. The zeros are the x-intercepts, the points where the parabola crosses the x-axis. And a parabola can have 3 types of zeros. It can have 1, 0. It can have 2 zeros, or it can have no zeros. Take a minute, look at these 3 pictures, and tell me which ones have 1 0, which one is no zeros, and which one is 2 zeros. I'll give you a minute. Maybe not a minute. Okay. Anyone? 1 0. Very good. Jorge or whoever else is watching this. This one here. 1 minute, 1 minute, 1 minute. No zeros. Thank you, Kaya. This last one. Anyone? Yes, 2 zeros. Thank you, Johnny. Okay. The last 2 things that are important are the y-intercept. That is the point where the parabola crosses the y-axis. This crosses the x-axis. And the very last one is the axis of symmetry, the imaginary line that goes through the vertex and cuts the parabola into 2 equal parts. And the Khan Academy assignment you did, if you did not do very well on that Khan Academy because there was problems with the ed puzzle, I suggest you go back and do it again. To be clear, this is the review of the lesson that we did between May 4th and May 8th. Thank you for watching.